When setting up a fiber link, one of the most obvious things to consider is the optical power budget. In other words, making sure that that delta between the output power of the transmitter and the sensitivity of the receiver is enough to cover the accumulated losses across a complete link. However, if we're talking about data rates of 100 gigabits and higher, there's another aspect that is becoming increasingly important. If you want to find out what it is and why it is so important, stick around and we'll check it out. What I'm talking about is dispersion, or to be more precise, chromatic dispersion. And basically what chromatic dispersion boils down to is the fact that light has slightly different traveling times depending on the wavelength. Let me explain. Now, a laser signal, spectrally speaking, is a very tight, so a very narrow signal, but it is monochromatic. And what that means is that for each individual pulse actually contains multiple wavelength components. And what you can see here in this animation is that these different wavelength components traveling at different speeds or different running times, the result of that actually is that this pulse signal starts to spread. And that actually then means that the slower wavelength components of this pulse actually start mixing with the faster wavelength components of an adjacent signal, meaning that a receiver actually isn't able to decode the signal anymore. Now, if we're talking about data rates of 100 gigabits and higher, this negative effect of a chromatic dispersion actually happens much sooner, or to be more precise, at a much shorter fiber length, because the pulse signals are much smaller, meaning that the pulse sequence is much faster. It is possible to compensate chromatic dispersion either with electrical or fiber optical techniques. So in other words, using dispersion compensating fiber or fiber Bragg grating dispersion compensators. However, it is imperative, especially for those higher data rates, to be able to actually compensate the dispersion. The fiber link really needs to be measured, or the dispersion of the fiber link needs to be measured accurately. So, I hope you learned something today and that you enjoyed this video. If so, please leave a comment. Also, maybe check out our homepage if you have any further questions on dispersion and dispersion compensators, or if you're looking for a dispersion compensator together with the optical transport solution that goes with it. Until then, see you in the next video. Bye-bye.